Welcome to Programming Fluency. This is section 10.1, the preprocessor. You have been writing hash include and hash define since your very first C program, but those lines are not normal C code. In this video, you will learn what they actually do and the tool that handles them. Let's begin. You have been writing hash include and hash define since your very first C program, but those lines look nothing like normal C code. There are no semicolons, no types, no function calls. In this video, you will learn what these lines actually do. They are handled by a tool called the preprocessor, which runs before the compiler ever sees your code. This is the plan for this video. First, what the preprocessor actually is. It is a text tool that rewrites your code before the compiler runs. Next, hash include and hash define. One pastes whole files into your code, the other replaces names with text. Then function-like macros. These are macros that take parameters, and we will see why parentheses matter so much. After that, conditional compilation. Hash if def and hash if indef let you include or exclude blocks of code. Finally, two common bugs, missing parentheses and a stray semicolon. Every C file starts with lines like these. They begin with a hash symbol, which nothing else in C does, and they have no semicolons and no types. This is the key idea. These lines are not C code at all. They are instructions for a tool called the preprocessor. The preprocessor runs before the compiler. It reads your file, follows every hash directive, and produces a rewritten version of your source. The compiler only ever sees the result. Now, the definition. The preprocessor is a text processing tool that runs before the C compiler. It does three main jobs. It inserts file contents with hash include. It replaces names with values using hash define. And it includes or excludes blocks of code with hash if def. The most important thing to remember is this. The preprocessor works on plain text. It does not understand C types, variables, or functions. It just copies text, replaces text, and pastes text. This makes it predictable, but it can also produce code that looks nothing like what you wrote. This figure shows the whole pipeline. When you run GCC on a program, 4 stages happen in order from left to right. The preprocessor runs first. It takes your .c file and pastes in the include files, replaces the define names, and resolves the conditional blocks. The result is expanded source, with no hash lines left at all. The compiler works only on that expanded source. After it come the assembler and the linker. You can see the preprocessor's output yourself. The -E flag tells GCC to run only the preprocessor and print the result. Let's look at hash include. It tells the preprocessor to find a file and paste its entire contents in place of the include line. It is literally a copy and paste. There are 2 forms shown here. Angle brackets tell the preprocessor to search the system directories, where standard headers like stdio.h live. Double quotes tell it to search your own directory first. Use quotes for your own headers and angle brackets for standard library headers. An include is recursive. If a header includes other headers, the preprocessor follows those too. A single include of stdio.h can pull in thousands of lines. Now hash define. Each define tells the preprocessor, wherever you see this name, replace it with this text. The substitution is purely textual. Watch what can go wrong. We define width as 10, height as 20, and area as width times height. Now look at B, it is 100 divided by area. After substitution, that becomes 100 divided by 10 times 20. Because divide and multiply have the same precedence and go left to right, this is 200, not 0. The preprocessor pasted the text without adding any parentheses. The fix is simple. Always wrap the replacement text in parentheses. Define area as open paren width times height close paren. A hash define can also take parameters. That makes it a function like macro. You put the parameter list right after the macro name with no space before the opening parenthesis. Look at square of x, defined as open paren x close paren times open paren x close paren close paren. When the preprocessor sees square of 5, it becomes open paren 5 close paren times open paren 5 close paren, which is 25. And square of 3 plus 1 becomes open paren 3 plus 1 close paren times open paren 3 plus 1 close paren, which is 4 times 4, 16. Notice every parameter and the whole body are wrapped in parentheses. That is exactly what keeps 3 plus 1 grouped correctly. This is a critical difference. A macro is not a function. It pastes its argument once for every place the parameter appears in the body. Look at square of I++. After expansion it becomes open paren I++ close paren times open paren I++ close paren. So I++ runs twice. That is undefined behavior in C, and the result is unpredictable. A real function would evaluate I++ once, so never pass expressions with side effects like ++ into a macro. Sometimes you want code to exist only under certain conditions. Debug output that disappears in production, or code that differs by platform. That is what conditional compilation is for. #def means if this macro is defined. The code between #def and #endif is included only when the macro exists. Here, debug is defined, so the debug printf is included. But if you remove the line #define debug, the preprocessor strips the debug print entirely. The compiler never sees it. It is as if the line does not exist. So debug code has zero cost in the production build. #ifIndef is the opposite of #ifdef. It means if this macro is not defined. Look at this pattern. If buffer size is not defined, then define it as 1024. This sets a default value. If nobody defined buffer size yet, it becomes 1024. But if it was already set, perhaps on the command line with gcc-D buffer size equals 4096, then this block is skipped and the existing value is kept. You will see this exact #ifIndef pattern again in the next video, when we build include guards. Let's summarize what the preprocessor does side by side. The left column shows what you write. The right column shows what the compiler actually sees. Your #include line becomes the pasted contents of the file. The name PI becomes the number 3.14, and so on. Square of 5 becomes open paren 5 close paren times open paren 5 close paren. And a #ifdef debug block, when debug is not defined, becomes nothing at all. It is removed. The compiler only ever sees the right-hand column. You can view it yourself anytime by running gcc-E on your file. This is the most common macro bug, missing parentheses. Look at double of x defined as x plus x with no parentheses. Now use it. 3 times double of 5. After expansion, that becomes 3 times 5 plus 5. Because multiply binds tighter than add, this is 15 plus 5, which is 20. You expected 3 times 10, which is 30. The preprocessor does not add parentheses. It just pastes text. The fix is always the same. Parenthesize every parameter in the entire body. Define double as open paren x close paren plus open paren x close paren close paren. This is a second common bug. A stray semicolon in a hash define. Look at this. Hash define size 10, semicolon. That trailing semicolon becomes part of the replacement text. So when you write int r of size, it expands to int r open bracket 10, semicolon close bracket. That is a compiler error. Remember, a hash define is not a C statement. It does not end with a semicolon. The fix is to remove it. Just write hash define size 10 with no semicolon. Let's recap. The preprocessor is a text tool that rewrites your source before the compiler runs. Hash include pastes a file's contents, and inclusion is recursive. Hash define replaces a name with text. Always parenthesize your macro parameters and bodies to avoid precedence bugs. Function like macros paste their arguments literally, so never pass expressions with side effects like I++. Hash if def and hash if ndef include or exclude whole blocks. Excluded code is stripped out completely, with zero cost. And watch out for two traps: missing parentheses in a macro and a stray semicolon in a hash define. Next, the preprocessor pastes whatever you include. But what should you put in those files? In the next video, you will write your own header files and protect them with include guards.